Hello, my little mathematicians. Today we're going to explore one of our final exam study guides. And you've been doing great all year, so now's your time to show off how brilliant you are. So go ahead, give them a try, and then press pause on the video, try it, unpause it, and check to see how you did. And remember, you can always check yourself on the answer key, and then just fast forward to the one that you need help with. All right, you got this. Let's go. So for these first setup here, it says that they want us to write out ratios depending upon whether you bought jerseys or hats. So here's the table explaining how many jerseys you got, and here's the table explaining how many hats you got. So it wants the ratio of Rams jerseys to Kings jerseys. So I like to always write out explaining what it is I'm comparing, so that way I don't mess it up. Okay, whatever they say first goes on top, and whatever they say second goes on bottom. That's important. If you mess it up, then it's not actually the correct ratio. So Rams jerseys, here's jerseys, and the Rams ones were 15. And they want the ratio of Rams to Kings, so Kings jerseys was 7. Can that reduce? No, it can't reduce. Now, technically, I know that this is an improper fraction, so you're going to be tempted to want to change it to a mixed number, but then it actually wouldn't be a ratio because you always want it something to something. And if it's a mixed number, like let's say 7 goes into 15 twice, and then you have 1/7 left over, how do you exactly explain how many Rams jerseys it is to Kings jerseys? Like that doesn't really make sense, right? So don't change them to mixed numbers. Keep them as improper fractions. And there you go. That's all there is to it. Okay, you go ahead and try the rest and then unpause the video and see how you did. Okay, you have Rams hats to Lakers hats. So here's the hats. The Rams hats was 20 and the Lakers hats was 30. Can you reduce that? Yeah, since they both end in 0, you know that 10 could go into both, and then those cancel out, and you just have a 2-to-3 ratio of Rams hats to Lakers hats. For number 3, it wanted the ratio of Rams hats to Rams jerseys. Ooh, okay, so Rams hats, this time I'm going to include it since they switch, to Rams jerseys. Okay, so what's more popular for Rams fans, the hats or the jerseys? Okay, the hats are more popular. And in what? What's the ratio? Remember that they always typically want the ratio in simplest form. So what can go into both 20 and 15? Well, since it ends in 0 and 5, you know 5 can. And 20 divided by 5 is 4, and 15 divided by 5 is 3. So that ratio is a 4-to-3 ratio. The ratio of Kings jerseys, okay, so Kings jerseys sold to all jerseys is what to what? Okay, so here's jerseys, and the Kings jerseys was 7 versus all jerseys. So do you include the Kings jerseys in that? Yeah, because that's part of the total, right? So looking at all the jerseys, it's 21 plus 7 plus 15. Okay. And so if you add all those together, you get 43. And then on top, you have 7. Can that reduce? Nope. If it was a 42, it could have, but that can't reduce because 7 can't go into 43. And 7's prime, so nothing else can go into 7. Okay, write the ratio of Lakers hats sold to non-Lakers hats sold. Okay, so Lakers to non-Lakers. And we're focusing on the hats. So in the hat section, we're focusing on the Lakers hats. That's 30. And then the non-Lakers hats. So this time, instead of doing the total, we're going to do everyone but the Lakers hats. So that would be 16 plus 20. And 16 plus 20 is 36. And 30 is on top. What can go into both 30 and 36? 6 can. Of course, if you notice 2 or 3, that would work as well, but that wasn't the greatest common factor, so then you just would have had to reduce it twice. 30 divided by 6 is 5, and 36 divided by 6 is 6. So your final ratio is a 5-to-6 ratio. Okay, if you haven't gotten any right yet, don't worry. This is your one. You got this. Okay, write the ratio of all jerseys to all hats. Okay, and if you get this one right, feel proud. Okay, all jerseys. So that's 21 plus 7 plus 15 to all hats, which is 30 plus 16 plus 20. Okay, because you're focusing on all the hats versus all the jerseys. If you add the top together, 21 plus 7 plus 15 is 43. We established that earlier. And 30 plus 16 plus 20 is 66. 43 is prime, and it can't go evenly into 66, so that is your final fully simplified ratio. All right, moving on. The next one says the relationship between sugar and flour in Glenda's cookie recipe is proportional. Fill out the table and answer the following question. So based on the information above, how much flour would be needed if Glenda used 9 cups of sugar? So as I said earlier, we're comparing flour to sugar. And they told me how much flour, so we don't know. When we don't know something, we use a variable. And then how much flour for every 9 cups of sugar. So let's put a 9 where the sugar goes. You're like, great, so what's my proportion then? Remember that a proportion is 2 ratios set equal to each other. So here's the one ratio from this sentence. The other ratio is going to come from this table up here. Well, from the table it said when you have 9 cups of flour, so 9 cups of flour, you have 3 cups of sugar. And when I go ahead and figure that out, let's see, always go toward your unknown. So go this way. How do you go from 3 to 9? That's if you multiply by 3. So then multiply this number by 3. 9 times 3 is 27. So that means when you have 9 cups of sugar, you're going to require 27 cups of flour. Okay. So that answered this question. And then it also wanted me to complete the table. So as we can see, like what's the pattern? As you go each time this way, you're multiplying by 3. So let's multiply this by 3. What's 5 times 3? 15. And then if you do this one, if you were asked to use 6 cups of sugar, then that's right, you would use 18 cups of flour. Okay, I know this isn't one of the questions, but bonus question for you. What if this was, I don't know, let's say 36 cups of flour? How many cups of sugar would that be? Okay, that's right. Hopefully you said 12. And how would you get that? Well, if each time you go this way, you're multiplying by 3. If you go back a step this way, that would be dividing by 3. So 36 divided by 3 would have given you that 12. Okay, so once you find the pattern, it always works the same. Okay, moving on. Let's try this next table. It looks a little bit tougher. It says the table below compares the number of pounds of apples with its cost. The relationship is proportional, which means it's going to stay consistent the whole time. Fill out the table and then answer the following question. Okay, so filling out the table. What do you notice from here to here? Well, since it's proportional, the pattern's not going to change. So what I would do is I would do this number divided by 5 and see what you get. Okay, if you do that, you get 3.5. So that means that 5 times 3.5 gives me 1750. Go ahead and test that and multiply 10 by 3.5. Okay, go ahead and type that in. What'd you get? 35. Let's test it one more time just to make sure it holds up. Okay, type in 15 times 3.5. Did you get 52.50? Perfect. All right, that's our pattern. So let's go ahead and multiply each of these by 3.5. Okay, so when you do 20 times 3.5, what do you get? Yep, $70. Okay, and when you do 25 times 3.5, you should have gotten $87.50. Perfect. Okay, so remember, you can always use a table to find the answer to a question, or you could set up a proportion. So they're saying, based on the information above, what would be the cost of 1 pound of apples? And you're like, I don't know. What is it? Okay, well, let's use any of the ones from this table. Okay, so if we're doing the cost per pounds of apples, if you have 1 pound of apples, how much money is that? Well, let's see. Let's just use this one. Looks the easiest. I'm going to use this row right here. I know that it's $35 for 10 pounds of apples. Okay, and since they all follow the same pattern, it doesn't matter which set you picked as long as you put the money on top and the pounds on bottom, it still would have worked out just fine. Okay, but I picked this one just because it looked like the easiest numbers. Now go ahead and go towards your unknown. Okay, and how do you go from 10 to 1? That's if you divide it by 10. So then take 35 and divide by 10. And what's 35 divided by 10? That's right, it's 3.5. So that means that 1 pound of apples costs how much? $3.50. Perfect. Okay, you just use a table to help you figure out what's that called when you're trying to find like how much it is for 1 pound? That's right, the unit rate. Okay. Look at you just moving on, mastering all these hard concepts from way back when. The next one is, yet again, still more proportions. It says if there are 560 calories in 8 ounces of ground beef, then how many calories are in 5 ounces of ground beef? And if you're asking yourself, how did she know that it was a proportion? Well, if you kind of see like 3 numbers and one of the items is talking about like 2 different things, and you have one item that's talked about twice, and then the other one they tell you one of the values and then it asks how much of that again, it's probably going to be a proportion. You're talking about 2 things. What are you talking about? Calories and ounces of ground beef. Okay, and the first sentence usually goes together, and then the second sentence usually goes together and creates your other ratio. So the first ratio says that there are 560 calories in 8 ounces of ground beef. So 560 goes with the calories, and 8 goes with the ounces of ground beef. Then it says how many calories. So we don't know. Let's put our variable with the number of calories. And the 5 is going to go where the ounces of ground beef goes because it's talking about 5 ounces of ground beef. Now I'm going to move towards the direction of my unknown. And can you easily go from 8 to 5? Not really. So when you can't do that shortcut method, what always works is cross products. So that's where you take the 2 numbers across from each other and multiply them together and set them equal to each other. So 8 is across from x, so multiply 8x. Set that equal to 5 times 560. So go ahead and type that into your calculator. 5 times 560 is 2,800. And 8x is just 8x. Now I don't want 8x, I want just x. So how do you go from 8x to x? If you divide by 8, because 8 divided by 8 is 1, and 1 times x is just x. I can do that as long as I divide by 8 on the other side. Well, 2,800 divided by 8 is 350. And what is x talking about? X was the number of calories. So when it's 5 ounces of ground beef, that is 350 calories. Okay, again, if you haven't tried pausing the video and trying it yourself and then unpausing it and coming back, why don't you go ahead and make sure you do so? Also, you can check yourself on the answer key and then just fast forward to all the ones that you need help on. Okay. Angel went to the grocery store and paid $18 for 8 pounds of apples. So money for pounds of apples. And it's 18 bucks for 8 pounds of apples. His sister Lily went to the same store and she purchased 3 pounds of apples. Okay, so where do I put that 3? Yes, on the bottom. Why? Because it was talking about the pounds of apples and we want to know how much it cost and the money is on top. So that's my unknown. Now, if we go towards our unknown, can you go easily from 8 to 3? Nope. So we're probably going to have to do cross products again. So 8 is across from the x, and 3 is across from the 18. Well, what is 3 times 18? That's 54. So to go from 8x to x, what would you do? You would divide by 8, because 8 divided by 8 is 1, and 1 times x is x. You can randomly decide to divide by 8 as long as you do the same thing to the other side. And 54 divided by 8 is 6.75 or $6.75 when you're buying 3 pounds of apples. Okay, so this is still a proportion problem for our next one, but this one is probably what comes up a lot more in life is when you're trying to do scale drawings. Okay, it says Max was drawing a blueprint of a house with a scale of 1 inch to 3 feet. So we're going from inches to feet. So this means that in the drawing, when you see 1 inch on this drawing, that represents 3 feet in real life. So then he wants to know, okay, if the actual length of the room is 24 feet. Where do I put that 24? Yep, on the bottom, because that's where feet is. Then how big does he need to draw it in the blueprint? How many inches? Okay, go towards your unknown. For this one, can you do the easy shortcut way, or do we have to do cross products? Yeah, you can do the easy shortcut, because 3 times what is 24? 8. So then 1 times 8 is 8. That means that he should make it his blueprint 8 inches long for that wall. Okay, next one says the ratio of sparkling water to lemonade in a fizzy lemonade recipe is 5:3. And this is really important. If you mess up that ratio, it just does not taste right. So we want to make sure that our ratio of water to lemonade is consistent. So it says the ratio of water to lemonade is 5:3. So whatever words come in that order, then these numbers follow that same pattern. Okay, so 5:3 is the water to lemonade. Then it says, okay, so if Mia uses 15 quarts of lemonade, where should I put that 15? Well, it's talking about the quarts of lemonade. And where's lemonade? On the bottom. Then how much sparkling water is needed? Well, we don't know, so that's my unknown. Go towards the direction of your unknown, so go that way. How do you go from 3 to 15? Multiply by 5. So 5 times 5 is 25. So that means that she should use 25 quarts of water if she's going to use 15 quarts of lemonade. All right. Hopefully you feel a little bit more comfortable when ratios or proportions come up. And a ratio and proportion is basically just fractions put into word problems. So now that we've showed we can master that, let's show off our basic multiplying and dividing of fractions. Okay, this very first one says 1/5 divided by 2/3. What's something important that I need to remember when I'm dealing with dividing with fractions? That's right. Hopefully that keep, change, flip popped into your head. Keep, change, flip. And what does that stand for? You keep the first fraction the same, you change the division sign to multiplication, and you flip that second fraction. Why? Because technically, like, we don't really think about it, but if you say, that you're dividing by 2, 4 divided by 2, in reality, keep, change, 2 is really 2 over 1, which is 1/2. And isn't dividing by 2 the same as multiplying by a half, right? And so I change this fraction to a half, and then you go 4 is on top, and 2 is on the bottom, and 4 divided by 2 is 2. Okay, now normally when it's something that easy of 4 times a half or 4 divided by 2, we do it in our head and we don't even really think about it, right? But here's like what's actually happening, and that's why we do keep, change, flip. Okay, so keep the first fraction the same, change division to multiplication, and flip that second fraction. Now look to see if anything can cross cancel. Nope. Nope. So then multiply across. 1 times 3 is 3. 5 times 2 is 10. Can it reduce? Done. Okay, the next one. Keep the first fraction the same. Change division to multiplication. Flip that second fraction. Can anything there cross cancel? Can anything there? Then multiply across. 4 times 2 is 8. And 5 times 1 is 5. Can it reduce? No. However, do I leave it like that? No, because that's an improper fraction. So I take the top and I divide it by the bottom. 5 goes into 8 once, and 1 times 5 is 5. When you subtract that, you get a remainder of 3. So you put your remainder over what you divided by. So my final answer is 1 3/5. Okay, Okay, again, if you haven't tried any yet yourself, make sure you pause the video and go ahead and give them a try. Then unpause it and join us. Okay, welcome back. Let's see how you did. You have 2/3. Change that to multiplication, and then this is originally 4/1, so then flip it and you have 1/4. For this one, hopefully you saw that these could cross cancel and you got 1/6. If you didn't see that those could cross cancel, you would have gotten 2/12, and then that 2/12 would have reduced to 1/6. But cross canceling just makes it easier so that you don't have to reduce at the end, especially when it has really big numbers. That makes a difference. Okay, for this one, to make a whole number a fraction, you just put it over 1, change division to multiplication, and flip that second fraction. That can't cross cancel, that can't cross cancel. So then you multiply across. 4 times 5 is 20, and 1 times 3 is 3. Now I'm going to keep this inside the house, and I'm going to put 3 outside the house, okay, because that was improper. So let's see what it is as a mixed number. 3 goes into 20 6 times. 3 times 6 is 18. Subtract that, you get a remainder of 2. So you put your remainder over what you divided by, and you get 6 2/3. Okay, last row. Put that over 1. So you have 8/1 divided by, what do you do with a mixed number? That's right, you change them to improper fractions. Okay, so I'm going to keep the denominator the same, multiply these two numbers, and add that numerator to it. So 3 times 10 is 30, plus 2 is 32. So 32/3 is the same thing as 10 2/3. Now that you have two fractions, I can go ahead and do my keep, change, flip. Do you see anything that can cross cancel? Yeah, 8 can go into both of these. 32 divided by 8 is 4, and 8 divided by 8 is 1. When you multiply across, on top you get 1 times 3 is 3, and on bottom 1 times 4 is 4. If you ever notice that during the video it's going too fast, don't forget you can always slow it down or speed it up if you just click on the settings for the speed. Okay, I have a mixed number and I want to change that to an improper. So 3 times 2 is 6, plus 2 is 8. Put that over 3, divided by, keep the denominator the same, 5 times 1 is 5, plus 3 is 8. And keep, change, flip. Okay, these 8s obviously are divisible by themselves. 8 divided by 8 is 1, and that 8 divided by 8 is 1 as well. Those can't cross cancel, so then just multiply across. 1 times 5 is 5, and 3 times 1 is 3 for the bottom. So I'm going to take the top, divide it by the bottom, and 3 goes into 5 once, which is 3. Subtract that, you get a remainder of 2. So I'm going to put my remainder over what I divided by, and you get 1 2/3. Okay, for my next one, you have 5, and 7 times 5 is 35, plus 4 is 39, divided by 10 on the bottom. 10 times 1 is 10, plus 3 is 13. And then keep, change, flip. What can go into both of these? Well, 13 can go into both of these. 13 divided by 3 is 3, and 13 divided by 13 is 1. Can these cross cancel? Yeah, if you divide by 5. Well, 10 divided by 5 is 2, and 5 divided by 5 is 1. When you multiply across, 3 times 2 is 6. And when you multiply across on the bottom, 1 times 1 is 1. And 6/1 is just 6. All right, are you feeling pretty proud of yourselves? Okay, last one for this section. 3 times 8 is 24, plus 1 is 25, divided by 3/1. Remember, a whole number, you just put it over 1. And now, bam, it's a fraction. But when you can't divide with fractions, so we got to do keep, change, flip. And on top, you get 25. On bottom, you get a 9. So you do 25 divided by 9. And 9 goes into 25 2 times, which is 18. and subtract that, you get a remainder of 7. So 7 over 9. 2 and 7/9 for your final answer. All right, we got this. Let's keep chugging away. For our next section, okay, it wants us to order the following from greatest to least or least to greatest. What does it say? It says from greatest to least. I like to underline the word greatest twice and the word least once, so that then it's just a visual. It wants it from big to small. Okay. Um, Now, another little trick, especially if it's something that involves negatives, I draw myself a little number line up at the top, and you have 1, 2, whatever. But what's mainly important is the negative side. Okay, I go -1, -2, -3. So it's just a visual for me to be able to see, okay, the smaller the negative number, the greater in value it actually is, because it's closer to becoming 0 and therefore closer to becoming a positive number. So if it's a bigger negative, that's actually like further in debt and further in the hole and further from 0. So that's actually lesser in value. Okay, so just keep that in mind. The other thing you want to take note of is um, if there's decimals involved, and there's like some have one number after the decimal and some have two numbers after the decimal, you want to make sure that they all have the same number of numbers after the decimal. Like, for instance, let's say that you had 0.27 and zero point 0.3. What's bigger, 0.27 or 0.3? Hopefully you said zero point 0.3, but the trap is to think that 0.27 is bigger. But if you had put the same number of numbers after the decimal and just added a little zero placement holder right there, then it would be easier to see, oh, hey, 30 cents is bigger than 27 cents. But the trap would be to think 27 is bigger than 3, but that's not really a 3, it's a 30. So these problems, it didn't really come up, but in other ones, if there's not the same number of numbers after the decimal, put zero placement holders there to help make it easier to see when you're comparing them. Okay, that's my 2 cents for that. Now let's actually move on to this problem at hand. Okay, the greatest. Obviously, whole numbers, positive numbers are going to be the biggest. So the biggest positive number I see is that 8.4. The next biggest positive is a 4. No more, so 0. Okay, and then for the negatives, okay, I'm going from greatest to least. So that's like greatest is this way and then heading that way. So I'm looking for the smallest negative number first. So the smallest negative would be that -3.5. The next smallest negative would be the -16.8. And finally, the last one would be -21.7. And just think, you're going from big to small. I'd rather have $8.40 than have $4, than have nothing rather than owe $3.50. And owing $3.50 is better than owing $16.80 or than owing $21.70. That's the worst position to be in. Okay. I just want to take my time on going through that because there's quite a few traps built into those types of problems. For my next one, this time it says least to greatest, and they love doing that on the test where you finally get the hang of it and then they switch it on you. So that's why I like to underline the word least once and the word greatest twice as a visual reminder. Hey, this time I'm going from small to big. So what's the smallest? Okay, so looking at the negatives, okay, so from this way to this way. Now I want the biggest negative. Well, the biggest negative I see is -12.7. Then it would be -10. Then -4.5. Then 3.7. And then 5.5 finally is the biggest of them all. Okay. The next thing they want us to do is compare using inequality signs. These are inequalities, and if neither one's bigger or greater than an equal sign. If they're both fractions, there's two things you could do. You could either have them get a common denominator. So I could do, well, 3 can become 6 if I just multiply by 2. So then multiply that by 2, you get a 4. Okay. And and then you're like, oh, hey, look, they're both 4, 6, so it's equals, right? Well, no, not really, because a positive is always going to be greater than a negative. So it's actually like that. If it wasn't easy to get common denominators, you can also change them both to decimals and then compare. However, for this one, I wouldn't have even bothered to do either of those things. I would have just glanced at it and said, oh, a positive versus negative. That one's bigger. Okay, for my next one, same thing. Positive versus a negative. That one's bigger. But remember, if they were both positive or both negative, then you need to either change them both to decimals or get a common denominator and then compare the numerators. Okay, moving on to the next concept, the absolute value. What is the absolute value? That's right, it's the distance a number is from 0. So if you looked on a number line, and here's 0, and here's negative 34, how far is negative 34 from 0? That's right, it's 34 away. Okay, and then here's 0 and 2. How far is 2 away from 0? It's 2 away. So no matter what, whenever you take the absolute value, whether it started as a negative or a positive, your answer is going to be positive because absolute value is talking about the distance a number is from 0. On a side note, the only way that you'd end up with a negative is if, let's say it was like this. What's the absolute value of 2? 2. And then what's the opposite of that? A negative 2, even if it was like this. Okay, what's the absolute value of negative 2? A 2. And what's the opposite of that? A negative. So the only time you end with a negative is if the negative was out in front of it. But if there is no negative out in front of the absolute value sign, it ends as a positive. Because the absolute value is always the distance it is from 0, and distances are always positive. Okay, moving on. I want to go ahead and make sure that I can distribute and then simplify these algebraic expressions as much as I can. So when it says to distribute or simplify, that means I take that number out in front and I multiply it to everything inside. So I have 5 times 2x. Well, 5 times 2 is 10, tack on an x. Now distribute that 5 to the 3y. 5 times 3 is 15, tack on the y. You can only combine like terms if, they're only like terms if they have the same variable attached. Is x the same as y? No, it's not. So then I can't combine those two terms. That's as far as I can go. Okay, go ahead and try these yourself. You paused it. Now you unpaused it and you're back with us. Let's see how you did. 4 times 5 is 20, tack on an A. Plus 4 times 2 is 8, tack on your B. Can you combine those? Nope, because A and B are not like terms. Okay, this time there's nothing to distribute, but I see the like terms right here of 3x and negative 2x. Make sure you actually circle the signs with it as well. Okay, so that way I remember that it's a negative 2x. And what is 3 minus 2? It's x. Because when you find your like terms, you just combine the coefficients. So 3 minus 2 is 1. Now let's do a different shape around these constants, because constants are just numbers by themselves. So those are like terms. 5 plus 3 is 8. And can I combine those? Nope, because that has a variable and that one doesn't. So that's as far as I can go. Okay, for my next one, I have a 3a and, oops, I can't combine it with that. So I just have a negative 3a. Then I got this guy. And there's no other b's, so I'm just going to write a 3b. Then finally, I have those two constants, so different shape for those ones. 2 plus 7 is 9. And there you go. That has an a, that has a b, that's a constant. So that's as far as I can go. That is fully simplified. Okay, last one for this page. It says, Mario bought some items from the book fair. Each pencil is $1.25. And each bookmark is 25 cents. He buys 4 bookmarks and 6 pencils. Create an expression that models this situation. Okay, so we're talking about pencils and bookmarks, right? So a pencil is $1.25. And how many pencils did he buy? He bought 6 of them. Okay, so pencils $1.25 for 6 pencils. Then a bookmark is 25 cents. So plus 25 cents for each bookmark. And he bought 4 bookmarks. Okay, and I used all the information. So create an expression that models this. So if I add how much he spent on the pencils and how much he spent on the bookmarks, that'll be the total that he spent. Now, technically, I could be done because all it said was to write an expression. That is an expression. If I wanted to simplify it, I could do 6 plus $1.25. Well, what is 6 times $1.25? That's $7.50. That's how much he spent on pencils. And what's 4 times 25? Well, that's $1. So that's how much he spent on bookmarks. That's another expression. I technically can add those. So $7.50 plus $1 means he spent $8.50 in all. So if they wanted the final answer and they said, how much money did he spend in all? That's the only right answer, $8.50. But if they asked for an expression, technically any of those are correct. But if you notice that there's like multiple blanks and it says write an expression and then simplify it and then what's the final answer, then they'd want it in that order. You know, like here's your initial thing, then you simplified, then you fully simplified to your final answer. Okay. All right. I hope you're feeling pretty proud of yourself. Let's move on to the next page. Now we're finally solving basic one-step equations. Remember, our goal is to isolate the variable. So we always want to get the variable by itself. How do we do that? We do what's called the inverse step, which means the opposite of what's happening. So for this one, okay, let's draw a line down from the equal sign. And here's my variable. So to get that by itself, what's preventing it from being alone? That 12. And what's happening with the 12? It's being added. So what's the opposite or inverse of adding 12? To subtract 12. Because 12 minus 12 is 0. It goes away. Now m's by itself. I can do that. I can do whatever I want as long as I do the same thing to the other side. So let's subtract 12 from there. 19 minus 12 is 7. Okay. Now, if you want to double check yourself, what you can do is you take the original equation, 12 plus, instead of m, we think m is 7, equals 19, and see if it makes a true statement. Well, what's 12 plus 7? It's 19. Equals, bring down that 19, true statement, so then yes, you know that 7 was indeed the right answer. Okay, so you can always check your equation if you want to see if you got it right. Okay. Always draw a line down from your equal sign. It just makes it easier to see where your variable is and what you want to get rid of. So here's where your variable is. I want to get rid of that minus 8. What's the inverse of subtracting 8? Adding 8. So those cancel because 8 minus 8 is 0. Now you're just left with r. So let's add 8 to this side. Well, 11 plus 8 is 19. Okay. Now, I'm going to bring that down. And here's where the D is this time. So this time I want to get rid of this 24 on this side. And if the 24 is being added, so the inverse of adding is to subtract. So let's subtract 24 from this side. 31 minus 24 is 7. And those cancel and bring down your D. Okay. Over here, this is where my variable is. So the 8 is preventing it from being alone. And the 8's being subtracted. So let's add 8 to get it to go away and get W by itself. I can only do that as long as I do the same thing to the other side. And 16 plus 8 is 24. Okay, if you haven't tried any of these yourself, let's do one more together, maybe maximum 2 more together, and then I want you to try them on your own. When you have 2 numbers touching each other, what does that mean when there's no sign between them? That means they're being multiplied. And what's the inverse of multiplying? To divide. Okay, so I'm going to divide by 18. Why? Because 18 divided by 18 is 1, and 1 times p is just p. So since I divided that side by 18, let's divide this side by 18. So 72 divided by 18, let's see, that's about 20-ish, and 20-ish goes into 72, so I'd say like 80, like 4 times. So let's try 18 times 4. It's too big, I can go smaller. And it actually went in perfectly. Okay, so my answer is 4. For the next one, when you have a fraction, what is that actually saying? It's saying y divided by 5. So what's the inverse of dividing by 5? To multiply by 5. Now those cross cancel and become 1, right? Just like, let's say I had this. Okay, so right here, these can't cross cancel, but these can, like 4 divided by 4 is 1. 4 divided by 4 is 1. And then you have 3 over 7, right? So when two numbers are diagonally across from each other in fractions, they cross cancel and become 1, right? And then you just multiply across. So that's essentially what I'm doing here. Okay, these 5s are diagonally across from each other, so they cancel each other out and become 1. And now you just have 1 times y, which is y. I can do that as long as I do the same thing to the other side. Since I randomly multiplied this by 5, let's multiply that side by 5. And 10 times 5 is 50. Okay, this time the x is over here and the 13 is attached to it. And so that means it's being multiplied. So the inverse of multiplying is to divide by 13. 13 divided by 13 is 1. So you have 1x equals, well, what's 52 divided by 13? I know 3 times 4 is 12, and 4 plus 1, 52. Perfect. It went in exactly 4 times. Okay, and then this last one, b is being divided by 7, and the inverse of dividing is to multiply. So those cancel and become 1. 1 times b is b. And so then let's multiply this side by 7. 49 times 7, you have 63. 28, 29, 30, 31, 30, 33. Sorry, 34. So 343 is my final answer. Okay, I hope you feel pretty smart. Now they want you to write and solve an equation from a word problem. It says a theater has S total seats. If there are 36 rows in the theater and each row has 28 seats, write and solve an equation to find out how many seats are in the whole theater. Okay, so kind of maybe like draw a little image here and let's like dumb it down a little. Let's say we have like 4 rows. 1, 2, 3, 4 rows. And let's say there's like 3 seats per row. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. What would you do to find the total number of seats? Well, there's 12, and the only numbers I would get was given was that there was 4 rows and then 3 seats per row, and I know that there's 12 total seats. So what do you do with the 4 and the 3 to get that? Oh, I multiplied them. Okay, so then that means I'm going to multiply the number of rows, which was 36, times the number of seats in each row, which was 28. And that's going to tell me the total number of seats. Now, what stinks is that sometimes they don't just let you write whatever equation you want. Sometimes they like say pick from this list. So once I have this, I can go ahead and solve it. And I know that 36 times 28 is what? 48. And that's 24, 25, 26, 27, 28. 0, 12 plus 1, 6 plus 1 is 7. So that's 8, 10 plus 1, 10. So you have 1,008 seats in the theater, okay? So if they give you other equations to choose from, then you can just plug in this for the S and see if it makes a true statement, okay? So if they said, hey, one of the options said S divided by 36 equals 28. Well, if you plugged in 1008 for S and divided that by 36, do you get 28? Yes, you do. Okay, so then that equation would work. And it makes sense because if you take the total number of seats and divide it by how many rows you have, that's going to equal how many seats are in each row, right? Like if this times this equals this, then this divided by either one of these should equal the other number. So that would mean that this divided by 28 should equal 36. Okay, so either of these equations would work. Okay, this isn't the only equation. Technically, you also could have said 28 times 36 equals S as one of your equations, because 36 times 28 is the same thing as 28 times 36. There's usually always 4 different equations that'll work, because there's 2 ways to write one of them, and then there's the 2 inverse ways to write it. All right, let's see about the next one. It says Peyton bought $D to the fast food restaurant. After buying a sandwich for $6.50 and a drink for $2.25, Payne has $8 left. Okay, so I brought some amount of money. So that's how much I have. When you spend money, what happens? It goes away. Okay, so I'm going away with how much out of my pocket? A $6.50 and a $2.25, right? So add these together and then subtract that from this. And then that's going to be equal to how much money I have left. Okay, so let's add the total amount of money that he spent. $6.50 plus $2.25. Means that he spent a total of $8.75. So I have to subtract that from however much he brought. And that's going to be equal to how much is left. So if I want to figure out how much was left, how do I solve for this D? Well, I need to get rid of this minus 875. So let's add 875 so that those cancel and I get D. I can do that as long as I add 875 to this side. Well, $8 plus $8.75 is $16.75. So if he spent $8.75 and he has $8 left, that means he brought a total of $16.75. That makes sense. Always talk through your answer and see if the logic makes sense, because the answer you get is based upon the equation that you created. And you don't know if you created the right equation, right? So always double check, and instead of just accepting it and moving on, double check that your answer makes sense. This totally makes sense. Okay, so I'm good to go. Let's move on. All right, we are on the last page, my friends. We got this. It says, for each word problem, write an equation, make a chart, and graph it on the coordinate plane. All right, we can do that. It says, Haley goes to middle school and has 6 different classes. Her parents really want her to do well in school. Haley's parents said they would give her $15 for each A that is on her report card. Wow, I wish my parents did that. Okay, so what am I talking about? I'm talking about the number of A's and then how much money you get for that. Okay, and actually, did I do that in the right order? So is it how many A's I get depends upon how much money I earned, or how much money I earned depends upon how many A's I get? That's right. The second way made more sense, huh? How much money I earn depends upon how many A's I actually get. I'm not going to earn that much if I don't get that many A's. And your dependent variable is always your Y, and your independent variable is always your X. This is your X-axis. That's your Y-axis. So that means this is talking about the money earned, and then this is talking about the number of A's. Remember, when you're creating the titles for these, it always has to be something that you can actually physically count if you're going to be asked to graph it. So there's 6 classes, so I can get 0 A's, 1, 2, 3, 4, 5, or technically all 6 A's, right? Okay, so how much should we make per A? We make 15 per A. So if you get 1 A, how much money do you get? $15. If you get 2 A's, you make another 15. So 15 and 15 is 30. And then add another 15 to that. If you get 1 more A, that's 45. Add another 15, that's 60. Add another 15, that's 75. Okay, but if you don't get any A's, how much money do you make? 0. What are you doing each time to your X to get to your Y? How do you get from here to here? Well, you can add 14, true. Okay, so what's 2 plus 14? 16, not 30. Okay, so it's not adding 14. Oh, what's another way? If you multiply by 15, right? 1 times 15 is 15. Does that pattern hold up? 2 times 15 is 30. 3 times 15 is 45. 4 times 15 is 60. And 5 times 15 is 75. 0 times 15 is also 0. So that pattern holds up the whole time. In order to get y, you're taking x and multiplying it by 15. So y is equal to 15x. That's your equation. Now they want you to graph it. I only need to go up to 5 for the number of a's. So I can probably like skip, not even one, let's skip like 2 spaces. 1, 2, there's a 1, 1, 2, so then there's a 2, 1, 2, there's a 3, 1, 2, there's a 4, there's a 5, 1, 2, there's a 6. Okay. For the amount of money, if I count by ones, I'm never going to make it to 75. I'd say let's count by fives. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80. Okay. So if you don't get any A's, you get 0 money. If you get 1 A, you get 15 bucks. So go over 1, up 15. Over 2, up 30. Over 3, up 45. And over 4, up 60. And over 5, up 75. Now, technically, we didn't figure out how much money you get for 6. However, what are you doing each time to get from dot to dot? You're going up 1, 2, 3 over 1, 2. Up 1, 2, 3 over 1, 2. Up 1, 2, 3 over 1, 2. So that means that for 6, how much money are you going to get? Well, what would that hit? You're going up by 5, so that's 80, 85, 90. So for all 6 A's, you would get $90. And that's the cool thing about these graphs is they always create a straight line, so then you can keep going and figure out something that wasn't even a part of your table. Okay, last problem. Dun, 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 dun. Says Brady is running a jogathon. His neighbor said that for every lap Brady runs, he will get, or he's going to donate $4 to him. Okay, so if he runs however many number of laps is how much money he's going to get donated on his behalf. Okay, so if you run 0 laps, sadly, you don't get any money. But if you run 1 lap, how much does he get? He's going to get $4 per lap. So 2 laps would earn him another 4. 4 and 4 make 8. 3 laps versus 4 versus 5. So add another 4 gives you 12. Add another 4 gives you 16. Add another $4 for another lap, you get 20 bucks. Okay, to get from 1 to 4, yes, you could add 3, but is 2 plus 3 8? Nope. So what's another way to get from 1 to 4? That's right, if you multiplied by 4. So 2 times 4 does give you the 8. 3 times 4 gives you that 12. 4 times 4 gives you that 16. So each time you're taking the x and you're multiplying it by 4 in order to get your y. Okay, this is your x, and it was talking about the number of laps. This was your y, and it was talking about how much money gets donated on your behalf. For the money, we want to go up to 20. So I probably count by 2s. But it's going to get really crammed. So maybe I'll count by 2s, but I'll only number every other one. So here's 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, and 40. Okay? And then for here, we only need to go up to 5, so let's space it out. There's 1, 2, 3, 4, 5, and let's go one more, 6. Okay, So if you don't run anything, sorry, you don't make anything. But if you run 1 lap, you get $4. 2 laps give you $8. 3 would give you 12. And 4 would give you 16. And 5 would give you $20. There you go. And then that way, in case they asked you, hey, how many laps would you need to run in order to make $40? Like, you could just follow it down and figure it out. All right, my little mathematicians, congratulations. You just finished an entire study guide summarizing all the concepts we've learned throughout this year. Good job. You've got this. You're going to do great.